Right, to name an organic compound, you need to first count the number of carbon atoms in the main carbon chain. Now you have 1, 2, 3 carbon atoms. But you need to note that we have two ways to count the number of atoms. From the right-hand side, that means from the hydroxyl group. Or you can count it from the left-hand side, that is from the double bond. So according to the priority, we will number the functional group of a hydroxyl group first, that is this carbon, and so on. Okay, so that you need to memorize the priority. Whenever you have the hydroxyl group and the double bond, you will number the hydroxyl group first. So after you have get the number of you have numbered the carbon atoms here, then you can try to construct the name. You have 3 carbons, right? 3 carbon atoms, so that's why you have prop. And then you have at the second carbon you have a double bond, so you have 2 in. And then at the first position of the carbon chain, then you have the hydroxyl group, so you have 1 OL. Right, so that is the answer, which have B. So question number 12, you just need to memorize the shape of the molecules. You have BF3, it is trigonoplanar, so that's why the answer is A, trigonoplanar. So number 13, you need to look at the statement one by one. The tendency of being reduced of the 6 ionic species increases in order as shown below. Okay, so for the metal ions, if it is very difficult to be reduced, that means the original metal atom is very reactive. Just like, for example, sodium atom and the barium atom. Sodium atom would be less reactive than barium atom because sodium ion is more readily to be reduced to become sodium atom than Ba2+. So Ba does not react with H+. So since H+ is more readily to be reduced, okay, so that's why when you put a metal Ba into H+, it will be more ready to be reduced to become H2. So that's why A will be incorrect statement. Ba actually can react with H+. So B, sodium has a stronger reducing power than Hg. So here, so if you look at the series, Hg2+ is very readily to be reduced back to the Hg. So that's why you can get the conclusion that Hg will be less reactive than sodium. Right, so since metals will give out electrons, so that's why it would have, if a metal can give out electrons readily, that means it has a stronger reducing power. That means forcing the others to accept the electrons. So CH2+ is the weakest oxidizing agent among the 6 species. So since it is the most readily species to be reduced, so that's why, in other words, it will be the strongest oxidizing agent, right, in order to let others to release electrons. So that's why it is not a correct statement again. So only B is correct. So for question number 14, you need to compare how much of heat is released from the reaction. That is to compare. So for question number 14, you are required to compare which pair of the substance would have given out the largest amount of heat. So first of all, you need to check each substance, whether you have the weak acid or weak alkali. Whenever you have a weak acid or weak alkali react, the amount of heat released would be less than those who have the strong acid and strong alkali. That is because some of the energy will be used to ionize, completely ionize the weak acid or weak alkali for the neutralization reaction. So next, what you need to consider is the number or mole of reaction being occurred, or in other words, the number of moles of H2O. Right? If more number of moles of H2O is being produced, then more amount of heat will be released. So A, 1 mole of HCl and 1 mole of KOH. So in total, you should have 1 mole of H2O being produced. But in B, you have 2 mole of H plus being produced by H2SO4 and 2 mole of KOH, which provide another 2 moles of KOH. Then that means H2SO4 and 2 moles of KOH would produce 2 moles of H2O instead. So the answer is B. So question number 15, which of the following statement concerning an iodine atom and a Cylon atom is all correct? So since Cylon and iodine is different elements, so they would not have the same number of protons. So since 131 is the mass number, which is number of protons plus number of neutrons. So if the number of protons of these two species are different, then the number of neutrons will have different number as well. So 2 is correct. So at last they have different number of outermost shell electrons. That is true because they will have different number of protons, and in an atom we have the same number of protons and electrons. So the answer should be D.